So here's another example that I want you guys to work out before you watch the video. So far we've actually worked out and computed the derivative of x squared is 2x, and I believe we worked out the derivative of x cubed is 3x squared. If you don't think you've seen this before, then you can do this one first if you want to, but we're going to try to figure out the derivative of x to the fourth, and I'm giving you just a little hint to make the expansion a little faster for you. I typically do this in class as sort of a big class exercise. So I am going to be careful with my notation. This notation means take the derivative of that. And so I find it easiest to go ahead and say, look, let's let f of x equal x to the fourth. And then I want to compute f prime of x, which is the limit as h goes to 0 of x plus h to the fourth minus x to the fourth all over h. And you can just expand this out if you know Pascal's triangle. That's helpful. But I did give you this sort of little hint here, which should make things a little bit easier. So I'm just going to go ahead and write this as the limit as h goes to 0 of expanding. I get x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth minus x to the fourth all over h. And you have to love how at the very end here this term and this term cancel, so we're left with just the middle terms. I'm actually going to take use of the fact that this is an iPad and just copy those, and now we can say, okay, this is the limit as h goes to 0 of this guy all over h. And so now we can cancel an h, right? I've got an h here, h, we can cancel an h. This is the limit as h goes to 0 of what? 4x cubed plus 6x squared, just an h, plus 4xh squared plus h cubed. H goes to 0, knocks out this, this, and this. And so you can see this limit is going to be exactly 4x cubed. And so the point is d dx of x to the fourth, which means take the derivative of x to the fourth, we get 4x cubed. And just to put this, again, in the context of tangent lines, what this is saying is for this function, you pick any x value that you want, and the slope of the tangent line to this function at your x value is 4 times that x value cubed. All right, so I want you to guess. You've seen the pattern here. The derivative of x squared, 2x, x cubed, 3x squared, x to the fourth, 4x cubed. And so you should be able to guess a pattern here. What do you think the derivative of x to the n is in general? Hopefully you said n x to the n minus 1. And this is known as the power rule. And it actually holds true not just for any positive integer, but actually any real number in this rule works. And we'll justify that later, but you can use this rule for now. And so why don't you go ahead and use the power rule to compute the derivative if this is your function f. And so hopefully you can write down f prime is 2016 x to the 2015. All right, so let's go ahead and end this video, and then we'll keep going in the next one.